Yes, students, despite of many instructions or giving different timelines, I am finding there are many students who have not completed the assignments. Repeatedly, I said assignments are necessary. All are there in WhatsApp group. There I do communicate. I do mention the names of the students who have not submitted. They are supposed to contact if any issues are there. There are students, they are in regular communication. Because of this problem, little delay will be there, but they are ready to complete and they will complete. I'm sure about that. But there are many students who are still careless despite of repeat instructions. Not only now, 1 month before I started to provide the instructions to complete that in time. Actually, whenever assignments were given, at that time only deadline was given. You were expected to complete. But latter stage of repeat instruction, that's a 1 month before that I'm saying. But still, sincerity, regularity is not there. You should complete that. As a part of internal evaluation, I will consider it. At that time, don't blame me, because if I get a chance or the opportunity or say responsibility, then I will allow that student to appear for examination. I'm talking about the practical examination. If student has completed the journal is a recording of doing, that's a notes. Plus, if we conduct any experiment as such, that at that time I will inform you those things to be completed. If you are not completed, then you will not be allowed for my practical examination. I should be clear in instruction. Therefore, I am giving this clarity about the task you need to complete. Assignments which are already assigned, you are supposed to complete. Fair chances are given. It is not that first time I am giving the information. Am I right?
Yes, sir.
Yes.
Yes. So
Yes,
you
sir.
are supposed to complete that task. Yes. And if you complete, then your internal evaluation will be done. If internal evaluation is done, if you are regular, if you are sincere, then you are the student of the college. Then I am ready to conduct your examination. Of course, a time has to decide. A department will take a decision. Last time it has happened. Last time is not last year. Last year students have completed well in advance. That where online examination was conducted, few experiments, online experiments were there. You could do that. If department decides and if shoulders the responsibility, I will do that. So that experiment you will complete on your cell phone or any device. And examination also similar experiment will be there. But to appear for examination, one necessary work is there, no? And that necessary work or part of that necessary work, major part of that necessary work will be assignment completion. Suppose if I would have told tomorrow is your examination and those who have submitted assignment, they only will appear for examination, then it will be somewhat injustice, no? It will be inhuman. I should inform in time. I should inform in advance. Therefore, I am sharing this information to you. Few students who are here, they also have not submitted, so they have to submit. And many are there, those who have not submitted but not present also. So I suggest you and request you communicate my message to them through these recordings. By up to the end of this week, they will come to know if they go through the recording. But you also have to communicate the message. Assignment completion is mandatory, is necessary. Do you agree that I was saying this repeatedly, right from the beginning?
Yes, sir.
Yes, sir.
Yes. Other reply. Mayuri, what is your view? Shefali said. I
Yes,
want
sir.
Yes,
to
sir.
reply from one. Tanay said. Yes, Mayuri, what's your view?
Yes,
Jagruti,
sir.
Gopal,
Yes, sir.
Suyash,
Yes, sir.
Manthan, whether you completed or not, that I am not asking. I am asking, was I not informing you right from the beginning? Complete the assignment, complete the assignment. That's my only question.
Yes, sir.
Yes, Bhupesh.
Yes, sir.
Yes, Shravani. Jagruti, not reply. Shravani has not replied. Yes, so
Sir,
all
I
you have
replied.
said that replied. Okay, good. So repeatedly I was saying that you have to complete the assignments. So again I am saying and requesting and suggesting to all you complete the assignments. Still few assignments will be there in due course. All assignments everyone has to complete and I can't do partiality there. If you have completed duly completed the assignments, then I can allow you to appear for the practical examination that I am going to conduct probably. Is my instruction clear to everyone?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
Yes,
sir.
yes. And please communicate this information to all your friends. At least you show the friendship in this way. They should not be in the trouble. I don't want to do injustice to anybody. And if I favor anybody, then that will be the injustice to those who have completed the assignments. And I can't tolerate that. I can't do that. I never did and will not do also. Whatever the rule or decision will be there will be uniform to all if one particular paper or practical examination is allotted to me to conduct. So in advance to inform, therefore just I shared my view with you. Okay, let me share the screen. See, with your consent, I continued that paper 1, but in paper 2, also few things are there. Study material is provided to you, is these notes. Are supposed to study that. That may help you in the examination. And examination will be of MCQ type. Students, I want to know, could you able to see this Word file
Yes,
document?
sir.
Yes, sir.
Yes.
Yeah.
Yes, sir.
So as per syllabus, each and every point is covered. First point is metallic and non-metallic character. About that detailed explanation, what is that metallic, non-metallic character? What are the reasons for the variation? That everything is what the discussed there. It means in periodic table, as we move from left to right across a period and top to down, top to bottom along a group, how the variation is there, why the variation is there, that point is covered. Next is oxidation state point. What is meant by oxidation state and how can we describe it by means of the various examples that I had given the answer. Few examples also are considered here. For example, H2O, what is the oxidation state on hydrogen? For oxygen, what is oxidation state? Those things are covered. In that oxidation state point, one important aspect is there, that's a inert pair effect. So what is meant by the inert pair effect? Where do we find that inert pair effect? An example, see here, it's a group 13 elements: aluminum, gallium, indium, and thallium. The inert pair effect increases as we go down in the group. Stores thallium, we find it more predominant. Thallium remains in the +1 oxidation state, predominantly, majoritically, stability of +1 oxidation state. In case of thallium is more, and that's due to the inert pair phenomenon. One interesting thing I informed to you, actually gold is gold because of not necessarily inert pair phenomenon, but one kind of the contraction. That's a lanthanoid contraction. There, gold is gold means gold is valuable. Gold is not more reactive. That tendency is related to the outer electron attraction, and that inert pair effect also talks similar way. Just for information, I am giving that it's inert pair effect, which comes under the oxidation state topic. Next is allotropy. About allotropy, you are aware, but we are discussing the allotropes other than carbon. Allotropes of elements. So few elements are discussed here. First, at the beginning, only in the rectangle, you will find oxygen. About the sulfur, also discussion done. Other examples also are quoted. So these examples you cannot go through. Further readings, if you want, then you can go through this website also. That additional website is also provided there. Next point is diagonal relationship between lithium and magnesium. Those are diagonally situated. By the way, they have relationship means they have the friendship or they have the similarity in the property. Why are they similar? Why do we find that diagonal relationship? That discussion is done. And all where you will find the main point will be radia, about which we had a discussion last time. Variation of atomic and ionic radia. Why had I emphasized on that point? Because that decides the properties on which the properties of the element do depend. Therefore, we're discussing those radia, ionic and the atomic radia. So the comparison of that atomic and the ionic radia, they are nearly same. So properties are nearly same. Charges are different, but the properties are what? Nearly same. Then on what ground we do say that these properties are of nearly same category, or how do they resemble? Resemblance of magnesium with lithium or lithium with magnesium. Almost here 8 points are given there. You should go through that, read that. I'm not saying that you have to by heart all, but conceptual clarity should be there. For example, if you consider a combination with the nitrogen, then you will get the nitrides. So nitride formation is a specialty of lithium, similar to the case for magnesium. Nitrides are not formed by the sodium or potassium or rubidium from the group 1 elements, but lithium can form. Same we are finding for the magnesium. So there is a similarity. Tendency to show the covalent characteristics has somewhat the similarity there, and therefore we are finding what the nitrides. So formation of nitride is a specialty of lithium as well as magnesium. So there is a resemblance. So here with this you will understand the reactivity of elements also and resemblance of those elements. Hence diagonal relationship. As like nitrides, similar way carbides are discussed, or other compounds, oxides you say, or hydroxides you can consider. Those how do behave explanations are given there. Are you following what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
The
Yes, sir.
second example of diagonal relationship is beryllium and aluminium. Again, they do show a different charges. Beryllium is from the group 2, so it can show the plus 2 dipositive, and aluminium from group 13, it shows a tripositive ion. But even though their properties are similar, I'm not saying same, they are similar, considerable resemblance is there. Again, the reason for that is given first. What are the reasons for diagonal relationship? And then later on, actually here the mix occur. Reasons are given A, B, C. These are the reasons. And then later on, this similarities in the properties. That point is given. Here also, 8 points are given for the similarity. Sorry, not 8. 13 points are given for the similarities in their properties. Just you have to go through, you have to understand. There also you'll find, as like nitrates you have found there for the lithium and the magnesium, similarly here also you'll find the nitrate formation. Other reactions also you will come across. Go through that. If doubts are there, then we can have the discussion. So one session I will keep for this open discussion regarding the paper 2. But before that, you have to study. But before to study, what you are going to study, you should know. Therefore, just I am going to highlight the things which are there in the paper 2 syllabus. Third point is the relationship between the boron and silicon. Means it is under the only one main point, diagonal relationship. And 3 diagonal relationships are there in your syllabus. Yes, what was the first diagonal relationship? Which elements were there?
Lithium and magnesium.
Right, it is the first. Second?
Beryllium and aluminium.
Right, and it's the third, boron and silicon. Again, as usual, there the reason was provided and then the resemblance in the properties was given there. Here 6 only the resembling properties are mentioned there. Then starts the point anomalous behavior, a different behavior. It is noted that the elements in the second period, means starting from the lithium, next element is beryllium, next element after gap is there 13 group is a boron, then carbon, then nitrogen, oxygen, fluorine, and last is what? Neon. Noble elements, that's a noble gases, 18 group element. We are not considering for properties in this year syllabus. But at third year, TY level, the group 18 elements are included in your syllabus. So up to group 17, group 1 to group 17. But transition elements are starting from the fourth period. But we are talking here about the second period. So only these 7 elements will come. Which one? Lithium to fluorine. Lithium atomic number is, yes, help me. Atomic number of lithium is
3.
3.
3. And atomic number of fluorine is?
9.
Yes. How many elements are there? 3 to 9.
9 elements.
No. 3 to 9.
6 elements.
7.
7.
7. Because third element, that's a atomic number 3 also have to consider, no? Lithium, beryllium, boron, carbon, nitrogen, oxygen, and the fluorine. So the 7 elements you are going to discuss. Anomalous behavior of lithium. Anomalous means differently. Why does it behave anomalously, differently? Lithium is showing same property like magnesium, but with other elements of the same group. It is not showing. Each element in the second group is different than the rest of the elements in the same group. And by which points or which aspect we can conclude lithium is different? That we are what going to conclude by means of 10 points here. Total 10 points are there for explaining differential ability of lithium compared to other elements. Yes, please unmute. Somewhere I'm finding disturbance there. Okay, no problem. It happens. Yes, Shravani, will you mute? Yeah, okay. I think she left. See, total 10 properties for distinguishing property of the lithium are given there. Lithium especially differs due to its size, small size, and its tendency to show the covalent characteristic, which is not by other first group elements. Okay, as lithium we have discussed first element, second element is beryllium. Again, the reason is given there, and then the main points of differences are covered there. Next, anomalous behavior of boron. Again, reason and the differences. 8 properties for the differences are mentioned there. Next element, carbon and its 7 properties of differences. Here, reason for anomalous behavior not given because it's same as was there for the lithium or other elements. So reason is not given. Distinguishing properties only are mentioned there. Similar is the case for nitrogen. Okay, for nitrogen, some additional aspects are mentioned there because there what happens after the transition series elements, d orbitals are there, and those show some addition in the properties of rest of the elements. Therefore, few things are mentioned there, especially in case of the nitrogen. It doesn't mean only before that family the transition elements are occurring are there, but properties related to the d orbitals are we are studying more in case of the nitrogen family, where non-metallic character is somewhat more. Therefore, we are discussing additional point. Similarly, about the oxygen, means reason and the points of differences. Fluorine, reason and the points of differences. So total such 7 elements we have what covered. Covered in the sense are there. Means it is up to the 6th page out of 21 pages. These many are the pages for the syllabus related to the elements in the periodic table. Is this point clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now see the few compounds, important compounds are there from industrial point of view or application point of view, from medicinal point of view. So their study is included. So how can we prepare them? So different methods for the preparation are given. You have to go through that. Means just you have to read that and try to what cognize it. Understanding is most important. And MCQ test, understanding will be tested more. And few things only you have to remember. So different methods are given. How can we obtain that the sodium carbonate and what are its applications? Different applications are what the given. You can go through that. It's simple. See, it's a very important application. Fire extinguisher. That's we say no CO2 gas comes. There's some reaction occurs in a cylinder, but to occur that reaction, which compound is used there? It's a sodium carbonate, a white powder. It remains. Maybe in your school or you go to any laboratories in hotels also. Nowadays it is not mandatory because fire extinguisher they have to keep. No, they are the different cadets of fire extinguisher, but their sodium carbonate is used to generate the carbon dioxide. When carbonate reacts with acid, carbon dioxide comes out. It's a chemistry. Means you see here and there different things you will find, and those things means matter, material. Without chemistry, it is not possible. Even you see simple aspect. A disinfectant, it's effective. That's a fungicide against the means anti-fungicide. You can say that is used. Just wait. Yeah, see here, sodium carbonate we discussed. Sodium bicarbonate is a mild basic, and sodium carbonate means washing soda that we say, that it is a strongly basic, and because of its alkaline tendency, again the applications are, and one of that application is what the disinfectant application, mild disinfectant. You go through that. A lot many applications are what brought there in order that you should get the interest. You will find many where these things are what applied. Okay, see here. Personal hygiene in toothpaste, sodium okay, now I'm so after sodium carbonate I'm coming to sodium bicarbonate. Sodium bicarbonate is used for better whitening, plaque removal, and that remains in the toothpaste. Means whatever the mesmerizing advertisements you find, but base behind that is the chemistry only. Sodium carbonate can be used, but sodium carbonate is not that much physiologically suitable. Sodium bicarbonate can, means it is our day-to-day application. Sodium bicarbonate readily you will get in the market, and you can also try. If you apply the teeth, you will find the whitening there. Nothing great in that. Different chewing-gums or different toothpaste, whatever they show there, it means they have that application. It doesn't mean sodium bicarbonate is the only one thing which can whiten the tooth, but it is one of the easy thing. Yes, students, are you following what I'm saying?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Even in sports, interesting application it is. Many do love the cricket. They like the cricket. Any game you can see, then there even a cooling bags. Cooling bags means if any injury occurs, no, then swelling immediately occurs. Means if fracture is there, then certainly swelling will be there. But sometimes if the further ligament injury is there, then also possibly swelling will be there. Or swelling is a natural spontaneous process. So for that, the cooling purpose, the bags remain. Those are sodium bicarbonate. Those who know that the medical field, when they give that one packet, they keep in the fridge, but a packet can store that cooling for some long duration. What remains in that packet? That packet is not the ice. That packet remains with what the sodium bicarbonate. Okay, and supplement for athletes in speed-based event, means running especially. Yeah. So interesting applications are given. You have to go through that, read that. It is interesting. Interesting means your applications of chemistry will improve. It was my purpose to focus on the application. Detailed applications are provided there. Okay. Actually, it was sodium bicarbonate. Whatever we're discussing is a sodium bicarbonate only. Now, sodium carbonate means it is a washing soda. Means previous discussions were regarding what the sodium bicarbonate only. Now it is what the sodium carbonate. It is a more strong base than the sodium bicarbonate. Sodium carbonate is strongly basic, and its applications are also given in what the detail. You go through that, and if any hair problem is there, I am putting one lecture for the general discussion. After this sodium carbonate, next point is the sodium chloride. Actually, it's a table salt, common salt, a very important chemical. Nowadays, one advertisement of the Nirma salt comes. What remains in that advertisements? We have that many acre plant in that area. I think 30,000 or something. They are giving that number, and we do manufacture the salt from sea water, ocean water. Likewise, they do advertise. Does it mean that sodium chloride is not obtained from seawater, or whatever other where sodium chloride is available is not obtained from seawater? If you see the traditional salt, even in Shiroda region, if you go, no, then there traditionally people do cover or get that salt. Have you seen that salt, traditional salt?
No, sir.
Yes, sir.
Okay, so traditional salt, that sodium chloride remains, but along with that magnesium salt, calcium salt, not chloride, sulfate also do what the remain there. And if you see the color of that traditional salt is a muddy category. It's not perfect white. Okay, so some treatment and all things necessary. Here, whatever they say, Nirma salt advertisement they do show, there they say that from seawater they are getting that. So stages are there with which they can separate the salt and measured sodium chloride they can what collect. In good old days, such branded salts were not there. Only traditional salts only were there. So salt intake people were doing. Salt use was there. Lot of salt use was there. But during the chemical manufacturing, many industries, sodium chloride remains byproduct. It's not a main product. It's a wastage, nearly wastage. Then somewhere before few decades, people got the idea. Okay, we can make commercially business with that waste. Means that sodium chloride, now if packed properly, somewhat purification done, packed properly, it was found. People are taking that. And in that one name, iodized namak, iodized salt. If added over there, then people get what the people will find the more advantage. And nowadays, if you see, traditional salt is used to less extent. Branded salt is used to more extent. Do you agree with me?
Yes,
Yes,
sir.
sir.
Yeah. So that branded salt is obtained from that industry. Industry means their plants are not to manufacture sodium chloride. Their plants are to manufacture other products, but sodium chloride remains a byproduct. And that byproduct is packed, purified, packed, and business can be done. Okay, they have to do business. It's true. My point of interest was in that the advertisement they show, no, in that Nirma salt, I think that advertisement is there. They are showing that they have the plant and they prepare the salt from seawater. They wanted to bring the traditionality. Traditionally, how it is prepared from the seawater, no? Methods are different, of course. Instrumentation also is different, but they wanted to bring the attention of the consumers to what? Seawater and the salt obtained from the seawater. It will be very wrong if we say that seawater possesses only sodium chloride. Perfectly wrong. Many other salts are there. But people get affinity to the, okay, from seawater they are getting. But many do not know that industry also sodium chloride is not purposely intentionally manufactured, but it happens as a byproduct and that we can use. Okay. So about sodium chloride, but from manufacturer point of view, how it can be done. So simple method is what given there. And by the way, uses of sodium chloride are mentioned.
Sir, how
Yes.
black salt is manufactured?
See, composition, no, it depends on the composition. Manufactured, if we know its composition, no, nowadays it is easy to manufacture. But whatever the traditionally we are getting, especially for the kettles, or even in our many food products also, no, that black salt is used. For medicine also that black salt is used. Few rocks do remain, or somewhere, no, that ingredients do remain. Those are necessary for us, essential elements that we find. So naturally it is obtained. Yes, are you following what I'm saying?
Yes, sir.
Yeah. And if composition is known, we can what manufacture. There's no issue at all. Nowadays, no, it is not an issue. But if few things are naturally there, no, then people do not pay the more attention towards that manufacturing. Only what they do naturally in raw format it remains, no. Somewhat the purification means what they do, recrystallization they do for purification. If your regular experimentation would have been there, then you would have understood recrystallization means what. Or in second semester, you will what understand recrystallization means what. That recrystallization is used for purification. Even one experiment you also can conduct. Traditional salt, whatever you get, no, just to dissolve that in water, saturated solution, and again evaporate that, saturate that, super saturate that. Again, salt will be there. Repeat, and slowly you will find color of that salt varies. It is because of recrystallization and getting the one of the component. And whatever the question is asked regarding the black salt, it has the different components. Yes, is it clear?
Yes, sir.
Yeah, components, essential elements also do remain. Because of that, the color changes. Yes, good. Then application of sodium chloride for water softening. Water softening means soft and hard water. Water is it is related to what the different concepts. So don't think hard means tough to touch. Soft means very spongy to touch. It is in that not in that way. It is from the chemistry point of view, softness and what the hardness. Next chemical is sodium hydroxide. How can we manufacture that? What are its properties and what are its applications? And chemistry point of view, sodium hydroxide, a very important chemical, very important chemical. Even the soap that we use, there also the basicity it remains. Alkalinity it shows. This sodium hydroxide has a vital role to play there. Okay, you can go to the, I quoted there many applications. Purpose was let us widen your the vision, broaden your the ideas regarding the chemistry, let you know what are the uses of the compounds. Therefore, more weightage I had given for the applications. Then is the calcium oxide, its applications. In day-to-day practice also you will find here and there we are using that calcium oxide. Next, calcium carbonate. So if you see on uses, I have spent more pages, uses of the various chemicals, preparation, and what the uses of the various chemicals. Okay, I'm running fast because study material is provided to you. You are supposed to work on that. If doubts are there, we can have the further discussion. Yeah. Now the compounds, various compounds we discuss, and out of that particular kind of the compounds. For example, carbides, nitrides, while explaining the anomalous behavior of the various elements or diagonal relationship, this point was there. So these are the different compounds. So how to obtain those carbides? Their preparation, nitrides, and few properties are discussed. Oxides and hydroxides. So in oxides also, simple, normal oxide is a one category. That's a MO category, means metal is a dipositive oxygen state. Second is a peroxide, hydrogen peroxide you might be knowing in medicine or as a medicine or in you can say hospitals also or medical shop you cannot get it easily available. Peroxide, hydrogen peroxide. Hydrogen peroxide different. I'm talking here about the metal peroxides. Metals also do form what the peroxide. So peroxide is one kind of oxide, and then superoxide, that aspect is there. Normal oxide and then the superoxide aspect. Superoxide aspect is there. Just wait. Okay, it is what not covered here, but oxygen in -2 okay, see, okay, it is actually O2 -2. It is superoxide. This, whatever I said, no, your normal oxide, actually it is what the superoxide. And also the change in that your notes, it is superoxide. The peroxide and normal oxide means here O -2. Oxygen carries -2 charge. Here O2 carries -2 charge. And in case of this MO, oxygen carries -2 charge. O -2. Thus that is called superoxide. Yes, are you following the correction that I did? You also can do that correction when you look at the notes. No, you can also do the addition. It is the page number 18. On page number 18, here it is shown there three types of oxides, and in that super oxide you have to write O minus, sorry, not minus 2, not sorry, not that, not just wait. It is the O2 minus means superoxide. O2 minus 2 means peroxide, and O minus 2 means it is what, oxide. So that changes you can what do just. Yes, is it clear what I said?
Yes, sir.
Yes, sir.
Yeah. Next is a hydroxide. For the sake of clarity, a comparison between the hydroxides of group 1 metals is here. It is found that cesium hydroxide is more stronger than lithium hydroxide. As we go from top to bottom, hydroxide strength increases. Generally, what I do, I ask question NaOH and KOH. Who is strong base or alkali? Then generally what happens? Student answers NaOH is a strong base because they heard about NaOH only, no more. But in true sense, compared to NaOH, KOH is a strong base, and reason for that is the sizes of the ions. Will anybody answer among Na plus and K plus who is small in size?
Na.
Na plus is small in size. Is it right?
Yes, sir.
Other students, yes, my question is Na plus and K plus who is smaller?
Yes, sir. Na is small.
Na plus is small. Smaller the cation, more will be the polarization. Polarization means that will decide the covalent bonding. Means in case of NaOH, there is predominantly ionic bonding, but relatively more covalent bonding. And because of that more covalent bonding, its dissociation, ionization is relatively less. With whom I am comparing? I am comparing it with KOH. So compared to KOH, NaOH dissociation is poor or less. So it produces less number of OH minus ions. And because of less number of OH minus ions, it is relatively weak base. Don't dare to say NaOH is a weak base. It is a strong base, but relative to KOH, it is weak. And KOH is weak compared to rubidium hydroxide, which is weak compared to cesium hydroxide. So how the hydroxide strength varies with example, the explanation is provided. Yes, are you following what I'm saying?
Yes, sir.
Yes.
Yes. Then we are coming to the environmental aspects. Means if you see your syllabus is divided how? First periodic table, the element, their study is done. Then important chemicals are studied. Important chemicals. Then carbide, nitride, oxide, hydroxide, there are special chemicals and their properties were discussed. Now we are coming for environmental studies where oxides of various non-metals to affect our environment. One among them is a oxide of carbon, carbon monoxide, carbon dioxide. So how can those obtain? Obtain in the sense they are produced. How can we control them? Is control measures. It is for oxide of carbon. Then oxide of sulfur and oxyacids. See, oxide of sulfur means sulfur dioxide or sulfur trioxide, and oxyacids means in that you have to add the hydrogen or H2, you can say H2SO4. Will anybody answer in which oxide I should add H2O so that I will get H2SO4? I mean, just pass that gas through water, you will get that acid. Means you can say hydrated oxide of that element. Question is, in which oxide of sulfur I have to add water, or which oxide of sulfur I should pass through water so that
SO
I will get H2SO4?
SO3.
Sulfur trioxide.
Sulfur trioxide. And to get this sulfurous acid H2SO3, I should pass sulfur dioxide. So if these
H2.
gases do remain
Sulfur
present in the
dioxide.
atmosphere, right? If these gases remain in the atmosphere, how can they remain in the atmosphere? See, we get the electricity. How do we get electricity? All plants are not hydel plants. Many plants are the thermal plants. And in thermal plants, we burn the coke. And by burning the coke, actually huge pollution occurs. Oxides of carbons are going. By the way, that coke remains with sulfur, and when it experiences a combustion, it forms the oxides of sulfur. And those oxides of sulfur, as they go, and during rainy season, the water will catch that sulfur dioxide or sulfur dioxide and it will fall, and acid rain may possible. So acid rain is one of the severe environmental aspect effect on what the environment, especially because of oxides of nitrogen and sulfur, it occurs. So oxides of carbon, oxides of sulfur, here now oxides of nitrogen are what discuss. Next point about the environmental aspect is a global warming. That's a global warming, a famous term. But exactly what is that? It's a globe. If you consider Earth as a globe, means atmosphere, air present on the Earth. Because of that, warming is there. And that warming is due to greenhouse effect. It's a related. Greenhouse means on Earth, if you say there is a white house, there is a blue house, there is a green house, white house, if you say is a red house, means soil we say. Blue house means water, green house means plants. Because of that house, because of those plants, we get one gas. That's a carbon dioxide gas, CO2. Or CO2 is used for that greenhouse. CO2 is needed for that what the greenhouse. So that greenhouse gas CO2, by the way, sometimes a crop like paddy can give the methane evolution, carbon dioxide, methane. So afterwards, carbon dioxide and moisture, when they come together, then they work or help for warming. How do they warm? It's the same effect as if like you sit in the bus. Nowadays it is difficult, but just you might have experienced. Plus, bus is on the platform and you are there in that bus and too much rush is there. What desire remain? When bus starts, when wind will come, because you find sweatening, warm effect occurs. Why warmth occurs? Because it's a dense public, so exhaust is there. That's a respiration. Carbon dioxide will exhaust, and that carbon dioxide, by the way, moisture remains. Carbon dioxide and moisture, when they remain, they cause the heating. To make this concept clear, you sit in one vehicle, say car, and close the windows and consider AC is not there. Then in that sealed car means I am talking about the closed window car, you will find more warming, more warmth, more sweetening compared to open window. Then you will say wind will affect. Yes, wind affects. But by the way, here, whichever the sun rays do come, glass is transparent, sun rays do come, they do interact and they cause the heating effect. And while returning, the sun rays change their frequency or the wavelength because they have to they interact. No, they lose their energy. They lose the energy means their wavelength will what increase, and that longer wavelength, those light, if they want to go out, they can't go. It happens like Abhimanyu. Those rays can enter, but they can't go out. Yes, students, are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
So those sun rays could not go out, so they remain there inside only, and they cause heating effect. That's a warming effect, and to that we say global warming. Now, this example of car I had given, one vehicle I had given. Then what about the globe? Yes, the same effect as we experience in the car is there in the globe. This greenhouse gases and moisture, if remains in more quantity, then we will find the warming effect. Sun rays will come on the earth, but while going out, they will not go out. Even though they want to go out, they will rebound, they will come back, causing more heat. That's a global warming. So what is that global warming and what are its consequences? How can we minimize that? Those points are discussed. And as I said before, other environmental aspect, important environmental aspect is acid rain. Because of oxides of carbon, nitrogen or sulfur, the acid rain may not possible. A pH of that water will be the less. So that point is what discussed. One example I like to share: Taj Mahal. Taj Mahal, deterioration in that the Taj Mahal rock or construction, and it is because of acid rain. Why? Because that construction, those marbles are there, carbonate content it is. When carbonate combines with acid, what happens? Yes, will anybody help me? If carbonate combines with acid, then what happens?
Carbonic acid forms.
No, carbonate combines with acid. Carbonate, sodium carbonate, calcium carbonate, such carbonates, if they combine with acid, carbon dioxide evolves and soluble thing obtains. So that rock, whichever is there, no, it will deteriorate, it will dissolve. Are you understanding what I'm saying?
Yes, sir.
Yeah. So deterioration of Taj Mahal, a historic place, that Taj Mahal is due to acid rain that indicates the pollution in nearby region. Okay. Similarly, one more aspect, photochemical smog, means it is called as a Los Angeles smog. Why it is called as such? You cannot go through that. You will understand that photochemical smog. So from environmental aspect, I covered here 3 points. One, global warming; second, acid rain; and third, photochemical smog. And here your syllabus completes. It is a work to you that you have to study it. Is it possible?
Yes, sir.
Yes, sir.
Yes.
Yes,
So
sir.
if you want, then I will prepare the assignment for that. If you want, otherwise, at least complete paper one. And this assignment, if you want, then will not be mandatory. But those paper one assignments are there; those are mandatory. For your exam preparation, study material is needed. Thorough discussion also we need to have to initiate that. I had provided you this study material. Yes, is my today's discussion clear to everyone?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, students. Is there any spontaneous question at this moment?
No, sir.
No, sir.
Yes, good, good. See, you said saying no also needs a humanity. It's a clarity. Don't always allow me to ask individually. Okay, if no question, then shall we stop now?
No question, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Okay, then,
Yes, sir.
students, I stop the recording and I declare here today's session is over.